Hi guys, we're starting stoichiometry today. This is the second video in chapter 7, and I really need you to make sure you get this stuff down, because if you don't, the next video is going to be much harder, okay? So please, as always, if you have any questions, reach out to me. Alright, so some stuff about reaction stoichiometry. The first thing you need to have is a balanced equation, because this is going to allow me to compare compounds to one another through a mole ratio. Okay, so I could relate this octane, there's 2 moles of octane for every 16 moles of oxygen. Or there's 18 moles of water to every 25 moles of oxygen. Or there's 25 moles of oxygen to every 2 moles of octane. So we can relate all of them to each other, but it has to be through a balanced equation, and those tell me the amount of moles those coefficients do. All right, so first we're going to talk about it in terms of pizza. So if I am trying to make a pizza at home, and let's say we don't have all the ingredients, this is a lab you're going to do with cooking, so that's good. So let's say we need a crust, 5 ounces of tomato sauce, and 2 cups of cheese to make a pizza. If I have enough of everything else and 6 cups of cheese, how many pizzas can I make? So we use this ratio of 2 cups to 1 pizza to tell me that I can make 3 pizzas. It's the same with moles and stoichiometry, except it's using moles instead of ingredients in a pizza. We already talked about that. Showing you the setup. So remember, whatever unit is here must go at the bottom, so they cross out. And then we just do our math. The mole ratio, so this piece is called a mole ratio. I know it doesn't tell you that. And that is the wanted moles. Sometimes they say desired. So those are the amount that you want over the number of given moles. And these come from coefficients. Sometimes students try to use other things, but they have to come from the coefficients. Okay, here's just a strategy you use. We will use mass a lot, mass to mass. We will switch compounds in the middle. If there is stoichiometry involved, it has to have this mole ratio piece. It doesn't have to have mass, but it has to have moles, and it has to be a ratio. Otherwise, it's just the same stuff we were doing before if it's mass or particles. So molecules, ions, things like that. All right, so again, first we're going to determine the mass of carbon dioxide, and it gave us grams of octane. So I would normally write grams of carbon, or grams question marks, that's what I'm looking for. And then I would write what we have here. All right, so I'm going to do the math. I'll do it at the bottom. So 3.6 times 10 to the 15 grams of octane. Remember, you've got to get your molar mass from the periodic table. So grams of octane goes to the bottom. And remember, that's 1 mole octane. Get my periodic table. Turn on my calculator. We've got 12.01 times 8. Plus 18.18, because it's 0.01. So I've got 114.26. Leave enough room. Okay, so our grams of octane cancel. Then the next step is our mole ratio. I have 2 moles of octane up in my my equation, to 16 moles carbon dioxide, and then in 1 mole of CO2, cross out my units, I have 44.01 grams CO2, cross out my moles. Okay, this is going to be a larger number because we're starting with a larger number, and that's okay. It just needs to make sense. And when I do the math, I get 1.11 times 10 to the 16 grams CO2. Okay, so yes, that's a large number, but we started with a large amount of octane, so that makes sense. So their number is, oh, it should just be 1.1. I'm sorry. I thought it was 3.60, but it was just 3.6. Make sure you're good on your sig figs, okay? I wasn't paying enough attention there. All right, so we've got another one. We've got, here's a number, 37.8 grams of carbon dioxide. What mass of glucose in grams? So we're looking for grams of this, and I have 37.8 grams of CO2. So you always start with your given. Likely carbon dioxide, we just did its mass, 44.01. 1 mole. Okay, cross out what we can. Then our moles of CO2 goes on bottom. Moles of glucose goes on top. Sorry, y'all, if something's being loud, it's because my dogs are being crazy. Cross out our moles. Don't forget, these numbers come from the coefficients. And I believe the mass of glucose is 80.18. Okay. Okay, our moles of glucose cancel. Then we do our math. Don't forget, if it's on bottom, divide by it. If it's on top, multiply it. So I get 25.8 grams of glucose. Alrighty, okay. Not gonna do that one. I do want to do one with kilograms. So notice this says kilograms and it wants the mass in kilograms. I do want to tell you, we're gonna do it the same way because kilograms and the 1,000 is gonna cancel on both sides. So I'm not even gonna pay attention to the 1,000. I'm gonna start with 25 kilograms. This is only because it's the same on top and bottom. 64.07. I'm going to show y'all how this works. .09. Okay, so when we're crossing things out, grams of SO2 will cancel with grams, sorry, that's not what I wanted. We'll cancel with, well, let's not cancel the grams. Just cancel SO2. Then moles of SO2 cancel, moles of H2SO4 cancel, and then this gram will cancel with this gram from SO2. So I'm left with kilograms H2SO4. Again, this only works if you have kilograms at the beginning and at the end. If you don't, you will have to go ahead and get rid of the kilograms, get it down to grams. I typed an extra, typed a plus at the end. Okay, 38.3. Nope, just 38 because of sig figs. So yes, that looks kind of funny. Sorry, I thought I'd have more numbers to write. So, and here in their conceptual plan, they are going through the 1,000. But look, these two completely cancel because they're opposites. And so you can just not include them. Okay, again, it has to be kilograms at the beginning and at the end in order for this to work. 38 kilograms. Okay, I'm going to do one more. 16 kilograms of nitrogen dioxide. Nitrogen dioxide is 46.01 grams, 1 mole. and we're looking for HNO3. Again, the same things cancel. I don't know why I wrote water. Habit, I guess. Okay, so I get 2 sig figs is 22 kilograms of nitric acid. That's an ugly 3. Okay, there we go. Better. So again, let me know if y'all have questions. I am going to stop today. I will post a practice. It'll have a key, but I really need you to make sure you have stoichiometry down, because if you don't, before we go to the next video, there's going to be at least 2 of these per problem. Okay, so you got to make sure you got this part down. Y'all have a great day.